Hey guys, welcome to question MM221 of the Maths Methods Fortify study guide. Now we've got a 10-mark question here. We can use our calculator, so just keep that in mind because we will probably use that later. So we've got this open plastic container, which means that it doesn't have a lid, so there's nothing at the top here. Used for storing food, has a base with width x centimeters, and we've got this diagram here. So this base has a width of x centimeters. This side length is 7x on 3 centimeters, and this the height is h. Okay. Now the question tells us that the container has a total surface area of 189 centimeters squared, or total external surface area. And we need to show that h is equal to 567 take 7x squared over 20x. Awesome. So first things first is to recognize that this surface area we're going to have to use in our equation. So we basically need to get h in terms of x, but the only way we can do that is by using this surface area here. So we know that the surface area is going to be this side, the back side, and the left, as well as the bottom, okay? It doesn't have a lid like the question said, so we've actually only got 5 sides that we need to add up. So we've got this, this bottom side, which is going to be x times 7x on 3, plus we've got this front side, which is going to be x times h, but then we've also got that again on the back side, right? So we're going to times that by 2, plus the sides, right? So 7x on 3 times h is going to give us this area here. But then we've actually got 2 of those sides, so we're going to times that by 2 as well. Awesome. So from here, what we can then do is just kind of expand all this out. So x times 7x on 3 is 7x squared over 3 plus 2xh plus 14xh on 3. Awesome. And this is our surface area, right? So we know that our surface area is equal to 189, so we can equate all this to 189. 189 equals 7x squared on 3 plus, now 2xh and 14xh on 3 are like terms, which means that, so 2xh is going to be the same as 6xh on 3. So I'll just write all this out. So 6xh on 3 plus 14xh on 3. Around here is your first mark, guys, as well. This is a 2-mark question, and this is your first mark. Now we're going to add all this together. So 7x squared on 3, these two can add together because they're like terms, which means we get 20xh over 3. We're going to multiply both sides by 3 to get rid of this denominator, which means we're going to get 567. Remember, you have your calculator, so you can use that. And our goal, remember, is to show that h is equal to this. So we're looking to get h by itself. I'm just going to bring this over here. 20xh is equal to 567 minus 7x squared. Now, we want to get h by itself, so again, we're going to divide both sides by 20x. 567 take 7x squared over 20x, as required. And that's our second mark. So that's part A. We're done. So this looks exactly the same as what we wanted, which means that that's our final answer. H equals 567 take 7x squared over 20x. So let's move on to part B. Now part B talks about volume, all right? So our question asks us, I'm just going to get rid of this. Our question asks us to find the volume V of x of the container. Actually rather show that it equals 7x 567 take 7x squared over 60. Awesome. Now, how do we figure out the volume of a rectangular prism? Length times width times height, right? So we're just going to multiply all these numbers together. So we get x times 7x on 3 times the height. And we know that the height from the previous question is given by 567 minus 7x squared over 20x. From here, this, you know what, let's just actually expand this out. So 7x squared, so x times 7x, times by that top is 567 take 7x squared over 3 times 20x is 60x. These x's can cancel out and we end up getting 7x outside of 5, 6, 7. Take 7x squared over 60 as required. That was part B. Part B is only 1 mark. So that was just the 1 mark, just showing that. And that's it. So let's move on to part C. Part C asks us to find the range of possible values for x. So the best way to do this is to recognize that our volume has to be positive, right? So we know that x can't be negative, but let's start by saying that the volume has to be greater than 0, right? Because it does. Okay, so this is probably the approach that you kind of need to take with these sort of questions. When it talks about the range of possible values for x, just thinking about, does this need to be positive or negative or whatever the context of the question is. And in this case, volume has to be greater than 0, obviously. Which means that because our volume is equal to this, 7x times 5, 6, 7 take 7x squared over 60 is greater than 0, right? And this is actually our first mark, so this is quite a hard step to kind of get to, just because it kind of requires a bit of thinking of, what makes x needing to be certain values of x. So you've actually got 1 mark there. Now we just need to rearrange to find what x is going to be. So 7x, so multiplying both sides by 60, that 60 kind of just cancels. So we get 5, 6, 7 take 7x squared is greater than 0. We can divide both sides by 7x technically, which gives us 5, 6, 7 take 7x squared is greater than 0. I mean, 7x is, it's like saying 7x is greater than 0 and 5, 6, 7 take 7x squared is also greater than 0. So if 7x is greater than 0, that means that x has to be greater than 0, which we already know because the side length has to be greater than 0. So 5, 6, 7 take 7x squared is greater than 0. 5, 6, 7 is greater than 7x squared. Greater than. And we divide both sides by 7 to get 81 is greater than x squared. And I'm just going to flip this around just to make this kind of easier to talk about. So x squared has to be less than 81, which means if you were to solve this in your calculator, you would get x is between -9 and 9, right? Because if x is like anything less than 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, we end up getting something less than 81. If it's over 9, it's going to be more than 81, and likewise for the negative. However, because x represents a side length, x has to be greater than 0, right? So x is greater than 0, which means that this whole negative side doesn't include, which means that it has to be between 0 and 9. So 0, x, 9. And this is our final answer, right? And we really need to make sure that we discount that negative version because a side length cannot be negative. We can't have a negative length. So that's our second mark and our final answer. So let's move on to part D. Part D challenges us to find dv dx, which is the derivative of the volume. So we know that volume is equal to this bit here, which means that our dv dx is just going to be our derivative of that. So let's start by saying that v of x is equal to, just going to rewrite this, 5, 6, 7 take 7x squared over 60. Now, to do derivatives, I like to separate them all out in terms of, so basically what I mean by that is actually just get rid of this fraction stuff. So what we're going to do is we're going to just expand this out to get, and you can use your calculator for this. We're going to get, so 7 times 5, 6, 7 is 1323x over 20. You would just do this in your CAS. Minus 49x cubed over 60. So separating these out makes it easier for us to actually differentiate this. This means that dv dx is equal to 1323 on 20 minus 49x squared over 20. It's our first mark. And then we basically just want to clean this up a little bit and say that 1323 minus 49x squared over 20 basically just joining these two together. Hence, the derivative is negative 49 x squared minus 27 over 20. That's our second mark. Now you can do this in your CAS, but because it's 2 marks, you just need to show a little bit of working like this. But that's part D done. As always, just let me know if you have any questions about it, but I think the biggest thing is just separating this fraction out so that you can actually derive it properly without just using your CAS. So let's move on to part E. Part E challenges us to find the dimensions of the container if the volume is at a maximum. All right, awesome. I probably should have left that dV dx there because we're going to need that, but I'm just going to rewrite it. So dV dx, like we found in the previous question, is equal to negative 49 x squared take 27 over 60. Sweet. So if our volume is at a maximum, that means that our derivative or our gradient is equal to 0, right? So as soon as you see maximum or minimum, think dy dx equals 0, or in this case, dv dx equals 0. So at max, dv dx equals 0. Therefore, 0 is equal to negative 49 x squared take 27 over 60. Now we can times both sides by, over 20, my bad. It's 20. Awesome. Now we can times both sides by 20, which gives us still 0 equals negative 49 x squared take 27. Divide both sides by negative 49, still gives us 0 equals x squared take 27, which means that x squared is equal to 27. X equals plus minus square root 27. Now because x has to be positive, we need to say that x is greater than 0, therefore x equals root 27. You would actually simplify this into 3 root 3 centimeters. So when we talk about dimensions, which is what the question is asking for, we're talking length, width, and height, all right? So this is our x value, which means that our width is 3 root 3 centimeters. So that's actually an important part as well. So width equals 3 root 3 centimeters. Cool, so that's our first mark right there. This is a 3-mark question. So now we can work out the length and the height based on the x value, right? So we know that the length is 7x on 3. So length equals 7x on 3. And we know that x is equal to 3 root 3. So we can say 7 times 3 root 3 over 3. These 3's can cancel and we get 7 root 3 centimeters. Length equals that. Awesome. So then we can say length equals 7 root 3 centimeters, and that's our second mark. Our third mark obviously comes from our height. So we know that our height is equal to, so from the previous questions, you can actually see this in part A. 5, 6, 7 take 7x squared over 20x. And we know that x is equal to 3 root 3, which means that 5, 6, 7 minus 7, 3 root 3 squared over 20 root 3. Now simplifying this, I would actually just do this straight into my CAS, and that gives us 3 root 3. Therefore, our height is equal to 3 root 3 centimeters, which is our third mark. So the biggest thing with this question is that we're dealing with the fact that the volume is at a maximum, which means that our dV dx is equal to 0. That's the whole key to this question. So guys, if you have any questions about any of MM221, hit me up in the comments below. But otherwise, I will see you in the next video and have a great day.